I've been creating this document, um, yeah, because these all are very important things, and only with the recordings you might not be able to write your notes. So documentation is very important for performance tuning. So yeah, fine. So let us start understanding the Java Heap architecture and how the memory allocation happens, right? So we all know that it is a very common thing, like we mostly might have heard about heap memory issues and all. So what exactly is Java Heap and why it is required, and um, how to understand the heap architecture, right? So to be precise, Java's heap memory is divided into multiple regions primarily managed by JVM. So this heap will be allocated when you start the server JVM. When you give the start server, server 1 or server 2, then your WebSphere application server, based on the parameters that you have provided, if you have not provided, the default parameters will be taken, and your server instance, your JVM, will ask your operating system to allocate the XMS and XMX values. So if your RAM on operating system consists like 8 GB, and you have allocated the maximum heap memory for JVM as 4 GB, then it will ask the operating system, and if your operating system has free memory available, then it will allocate 4 GB to this JVM. So day before yesterday, I was working for one of the Saudi clients on WebLogic server. So what happened is there. Let me give you a scenario here. So the RAM on Windows was some 88 GB. I tried starting WebLogic server. So it says, actually it didn't start. It says uh, could could not uh, allocate memory further. So there was 88 GB, but still it could not allocate. So the JVM parameters, the heap parameters was XMS 4 GB and XNX. So this is XMS. Then why it could not allocate the memory to this server? Because the maximum is 8 GB and the RAM available was 88 GB. Why? So when I checked the task manager, the available memory, the available memory was very less. And when I checked the processes, there was a security or a monitoring agent. Okay, that was occupying like 50 to 60%. Because of this, uh, tool, the Windows has allocated maximum memory to this service, and it does not have enough RAM to allocate it to the new service that have started, which is WebLogic. here, primarily managed by JVM, the memory model consists of heap memory and non-heap memory, and memory allocation is handled via garbage collection. So whenever you start a server, based on the values that are provided, the heap memory will be allocated to any server. It is not only WebLogic but any server. So if your operating system does not have enough memory, then your server will not start, because when you see the server startup behavior, first thing it requires it does some validations and some prerequisites. One of these prerequisites, memory. First, it needs memory. So when the memory is allocated, then it creates thread pool and connection pool. It will load the classes and application deployments, deployment classes. Just a minute. Okay. Um, yeah. So it will load the application classes and WebSphere libraries, all these things. So when all these are successfully uh, satisfied, then your server will be started with the deployed applications. All right. So this memory is very important because all the data will be stored in the memory. Even the threads, it stores some information. It stores the session information, it stores the status, it stores the application related objects. So there are multiple things that it stores. So in order to store all these things, it needs memory. So that memory is allocated to the threads which handles the request by the heap memory, right? So this heap memory is managed by garbage collection. So this heap memory, it is not like once it is full, then another heap will be allocated. No, uh, heap memory will be managed by GC, which is called garbage. This it removes the unused objects in the heap memory, and the cleared objects. So once the objects are cleared, memory will be reclaimed. Once it is reclaimed, then you will have enough memory for other requests to create objects, right? So this is a process. So when it comes to Java heap architecture, let us have a small diagram to understand it better. So there are different regions, or we can call segments. Just bear with me. It takes some time. I'll be faster to create this, but again, Perfect. So uh, much better, not a problem. Uh, so it has got different regions. The first one is called Eden space, and there is S0, and again there is, and this is old generation, and this is on heap. So non-heap in JDK8 it is called metaspace. It was called perm generation. So now in JDK8 it is renamed as metaspace, and some changes have been done to optimize the performance, right? So we will get to know how these objects were created in the heap. We will get to know that in the in a while. But before that, let us understand this heap architecture. So this is the heap. Until here, this is the heap. Now this one, this is no heap. Now okay, just let us adjust. It is playing. I don't know. Only one. Fine. So this is young generation, and this is old generation. Now young generation, old generation. So heap memory is divided into two major parts. One is Java heap, and the other one is non-heap. So non-heap, this is not used for object creation. This is mainly for your application classes, right? So we'll talk about this later. And this is your actual heap: Eden space, survivor space 0, survivor space 1, and old generation. So again, this heap is divided into two major regions. One is young generation and the other one is old generation. Okay. So young generation has three segments: Eden space, survivor 0, survivor 1. And old generation is just, it is also called as tenure. Tenure. Okay. So let me just, okay, fine. I have kept it like various sizes, the text, these boxes, rectangles, because of some reason. So yeah, here whenever a request comes in, you know, there will be multiple requests. These requests will be assigned with a thread. So you have a thread pool. So this is a stack of the thread pool, and each one request will be allocated with one thread. So these threads need to store the information. It contains some information, right? So what it wants from the application. For example, one request arrived and it is assigned with one thread from the thread pool, and this request is like www dot access on slash um, personal banking slash login. So it is this URL says that okay, from Axis Bank there are multiple types of banking. This is a personal or a customer banking module, and it needs a login page. So login page contains username and password, right? So there are two objects required. Actually one object but stores two values. So in order to store the login details, this particular thread needs memory, and that memory is allocated by heap memory, Java heap. Out of Java heap, the first segment is hidden space. So from the hidden space and of some memory will be allocated in the form of object. Like this, multiple objects are created for multiple threads. Guys, you're following, understanding. I'm going very slowly actually, because these concepts are very important. Unless you understand the concept and things that happen in the background, you won't be able to tune with the fine parameters, right? So objects will be created when the memory from hidden space will be allocated to the threads. Now, this thread uses the memory for the entire transaction until the entire processing by your JVM is complete. So this is your JVM. So the memory will be inside the JVM, right? Okay. So the JVM processes, it contains the different containers, web container, AJP container, connection pool, and different resources. So whatever the resources are required, everything will be completed. Once the request, the thread completes its execution, it will leave the object reference back in the hidden space. Or if it is taking more time, then these objects will be moved to the next segment. If it is living longer, and parallelly garbage collection is happening here. So garbage collection, it is an automatic process mechanism. It is a mechanism uh, for clearing objects, the heap. GC. So let us say that this object has completed the transaction and left the memory in the back to the hidden space. So frequently lived objects, always in hidden space, lived objects will be uh, cleared by one object is cleared, so the other two objects survived the GC cycle. So they have survived and they have moved to survivor space 0. And here the object is still referenced by these threads. Okay, and this object is cleared, meaning the memory is reclaimed. For the newer request, again the memory will be allocated continuously from the by the event space, and garbage collection mechanism will be clearing out the objects, the frequently lived objects. This continuously happens, you know, uh, concurrently in the heap memory, and the objects that are still referenced in the sense it is still the thread is still holding the object because some background operation is going on. The JVM is still processing the request. So here again the GC will be performing its mechanism. It will be still clearing out objects based on the timeout values, right? So again the objects that survive the GC will move to survivor space 1, and here also the same process. If still the thread is holding the reference, these long-lived objects will be moved to old generation. Actually, old generation will be bigger and hidden space will be smaller. Survivor spaces will be very small when compared to hidden space and old generation. So we can also tune this one. We can define how much memory to give for hidden space, how much memory for these two, and how much memory for this one, right? So we can also tune this one. We'll see that when we take a case study. So here the GC happens and it clears the memory uh, by clearing the object references from these regions. So the GC happens in multiple phases. The GC that happens in young generation, which includes these three segments, is called minor GC.
Sayed, which three are called minor GC?
These three: Eden space, S0,
Okay,
and
S1. Okay.
this is minor GC. Let me put it. This is minor GC that happens in young generation, and this is in old generation. GC is called the GC that occurs is called major GC. Why major GC? Because this size of old generation will be bigger and it will take some time to clear the objects. Whereas Eden space is the first region where frequently lived objects exist, and if the user is accessing something very it is few seconds, like 1 or 2 seconds, and he has completed his transaction, those kinds of objects will be cleared when GC happens, like the minor GC. Okay, and if they survive this GC cycle, all the survived objects will be moved to S0, and if they survive S0, it will be moved to S1. So in right now there are two objects in S0. So when the minor GC occurs, If one object is not referenced any longer in S0, this object will be cleared and memory will be reclaimed. And the other object which is still under processing, the thread that is holding this object is still under processing, that will be moved to S1. And here again, if it is still happening, the request is still under process, then this will be moved to old generation. So old generation is a place where long lived objects are present. Long lived objects. These long lived objects will be cleared by major G. It claims huge memory. Whereas minor GC that occurs in young generation where short lived objects are present, it claims memory more frequently, uh, but in smaller uh, sizes, memory smaller chunks, mostly in MBs. But when major GC happen, it will be in GBs, right? So are we clear up until now? Jivan, Mangla? Okay,
Yes,
okay,
yes.
yeah, great. So now there is one more thing called full GC. This happens and old generation simultaneously. Why it happens? Already there is young generation and old generation. The minor GC is happening frequently, and major GC is happening, less frequently, but claiming the memory. But sometimes full GC also happens. Full GC. What is full GC? Clearing the objects on both young and old generations simultaneously. So this happens, full GC occurs the Java heap when the XNX value is utilized. I mean, it is full. So meaning what? When the memory is full, then full GC cycle occurs, reclaiming um, huge memory. So in this, it will clear the unreferenced long long-lived objects. Now, so we have understood how this heap works, right? So the different regions, the different segments, young generation, old generation, minor GC, major GC, and how the objects move from one region to another region, and which objects will be cleared from hidden space and which objects will be cleared from old generation. So we are clear on this. Now, how the object gets created, right? So let us see how it gets created. Before that, let us just understand, this is for your reference. I have explained everything here. So let us go through this. You can understand it better. So young generation, hidden space and survivor spaces, S0, S1. So new objects are allocated here first. And objects that survive a minor GC cycle are moved between these two spaces before being promoted to the old generation. So as I said, if they survive the minor GC, they will be promoted to the older generation. And how this the GC moves the objects from one segment to another segment, on what value? Yes,